The Smiling Sun. When solar physics meets human perception on October 26, 2022, an image captured by NASA's Solar Dynamics Observatory went viral across the globe. It wasn't due to a solar flare, nor a major geomagnetic event. Instead, it was something far more unexpected. The sun, captured in ultraviolet light, appeared to be smiling. Two dark circular patches, shaped like eyes, a longer curved area beneath them resembling a wide grin. To scientists, it was simply a snapshot of solar activity. To the public, it looked like a cosmic emoji, an enormous star burning at millions of degrees, smiling back at Earth. Though the resemblance was purely coincidental, the image ignited interest across scientific, cultural, and educational community. This is a documentary examination of what the smiling sun really was, how such features form, and why our brains are drawn to such patterns, even in the heart of a star. Part 1. The source. NASA Solar Dynamics Observatory 134. The image came from NASA Solar Dynamics Observatory, or SDO, a spacecraft launched in 2010 and still active today. The SDO orbits Earth in a geosynchronous orbit, where it continuously watches the sun. It is equipped with multiple instruments that monitor solar activity in extreme detail, using various wavelengths of light invisible to the human eye. One of those instruments, the Atmospheric Imaging Assembly, AIA, captures high-resolution images of the solar corona in 10 different wavelengths, including 193 angstroms, an extreme ultraviolet wavelength ideal for observing coronal holes. On that day in October, the SDO-AIA detected 3 large, cool regions on the sun's surface, regions where the magnetic field allowed solar wind to escape. These areas appeared darker in the image, creating the illusion of 2 eyes and a smile. But what exactly are these darker patches? And why do they appear this way? Coronal holes are regions on the sun's outer atmosphere, or corona, where magnetic field lines are open to space. Unlike closed-loop magnetic structures, which trap hot plasma and emit intense light, open field lines allow plasma to escape, forming high-speed streams of solar wind. These areas are cooler and less dense than their surroundings, so they appear darker in extreme ultraviolet and X-ray images. Coronal holes can last for days, weeks, or even months. They are not unusual. In fact, they are common features during the declining and low phases of the solar cycle. The eyes and mouth of the so-called smiling sun were all large coronal holes positioned by chance in a pattern that resembled a face. They had no special meaning in and of themselves, but the arrangement was striking. It was an alignment of magnetically active zones during a period of increasing solar activity. A pattern formed entirely by natural processes in plasma and magnetic field dynamics. So why did the public react so strongly to the image? The answer lies in a psychological phenomenon known as pareidolia, the tendency of the human mind to perceive familiar patterns, particularly faces where none exist. This behavior is deeply rooted in our evolutionary biology. Humans are social animals. The ability to detect faces and emotional expressions quickly, even in poor visibility, has been critical for survival. This neural pattern recognition is so sensitive that it often triggers false positives. That's why we see faces in clouds, outlets, tree bark, and yes, even in the sun. The smiling sun image aligned just enough to trigger that response. 2 dark circular shapes, a long curve, horizontal symmetry. That's all it takes for the brain to say, this is a face. While the image was visually amusing, the features it revealed were scientifically significant. Coronal holes are major contributors to solar wind. The solar wind, when directed toward Earth, interacts with our planet's magnetosphere, compressing it and injecting energy into the upper atmosphere. This can lead to geomagnetic storms, auroras, and in stronger events, disruptions to radio communication, GPS systems, and electrical grids. In fact, following the date of this image, Earth experienced a moderate geomagnetic storm linked to the coronal holes captured in the smiling pattern. The smile may have looked friendly, but the processes behind it are anything but gentle. This is space weather, and it has real consequences for life and technology on Earth. NASA SDO uses the Atmospheric Imaging Assembly to capture full-disk images of the sun every 10 seconds in multiple wavelengths. The 193 angstrom channel, which produced the smiling sun image, is sensitive to the emission of iron ions in the corona at temperatures of around 1.25 million Kelvin. This data helps scientists study coronal holes, solar flares, and the solar wind source regions. The instrument combines these data with precise time-stamped magnetic field measurements from the helioseismic and magnetic imager HMI, another key SDO instrument. Together, these tools provide a nearly continuous high-resolution view of the sun's surface and atmosphere, helping researchers model and forecast solar behavior that affects space weather near Earth. Part 6. Public Engagement in Scientific Communication 1530-1730, NASA release of the image, accompanied by a light-hearted caption comparing it to a jack-o'-lantern, led to widespread sharing and media coverage. The image was not only entertaining, it also served as a valuable educational tool. Science communicators used it to explain concepts like coronal holes, solar wind, magnetic fields, and the ultraviolet spectrum. Astronomers emphasized that the sun constantly changes, and the apparent smile was purely coincidental, a natural outcome of dynamic plasma behavior. Still, the public's fascination with the image highlights the importance of space-based observation missions. They not only serve science, they connect people to the cosmos in a visual and emotional way. The smiling sun was not a sign, a prediction, or an omen. It was a photograph of our star taken in a specific wavelength at a specific time, when solar activity formed a recognizable pattern. The image teaches us about the behavior of magnetic fields, the structure of the corona, and the nature of human perception. It also reminds us that even in an age of precision science, we remain instinctively human, drawn to familiarity, even in the heart of a star. Solar activity continues to shape our technology, our environment, and our understanding of the Sun-Earth connection. This image may fade from headlines, but it marks a moment where science, imagery, and public curiosity briefly aligned, much like the features in the photo itself. If this documentary helped deepen your understanding of solar physics instrumentation and how we observe our nearest star, please like, subscribe, and share your thoughts in the comments below. Your engagement supports the effort to make space science accessible, accurate, and exciting. Thank you for watching.